Hello, my lovely viewers. Good evening and welcome to Eugene TV. Let's take a look at this question. And this question is based on solubility. The question says, calculate the solubility of 10.1 gram of potassium triazonitrate 5 dissolved in 50 cl of distilled water at 25 degrees Celsius, given that atomic mass of potassium equal to 39, nitrogen equal to 14, and oxygen equal to 16. We have the options here, option A to E. If you know the answers, please drop the answers in the comment section. Drop the answers in the comment section. Alright, before we solve this question, let's quickly look at what is called solubility. Alright, solubility can be defined in three ways. Number one, solubility simply means the extent to which an amount of a given substance can dissolve in a given volume of solution. Or we can say that solubility can be defined as the amount of substance in moles or in gram that can dissolve in 1000 cl of solution at a particular temperature. Or we can also say that solubility can be defined as the amount of substances that can dissolve in a given volume of solution at a particular temperature. So if you are asked this question, how do we solve a problem like this? Come with me as we solve this problem. Okay, we go this way, we say solution. Alright, if we have any problem on solubility, we need to understand what we are looking for, since we say that solubility simply means the amount of substances that can dissolve in a given volume of solvent at a particular temperature. Alright, so we are going to use a very simple formula to solve this problem. And the formula is this. When we say solubility is equal to mass. This mass is the mass of the salt all over molar mass. Okay, for the purpose of our study here, I'm going to represent molar mass with capital letter M. Alright, times 1000 all over volume. And 1000 all over volume. And this volume is going to be in cm cube. Volume in cm cube. Okay, so look at the question very well, that we are going to use this expression to solve this problem. There are other ways we can use to solve this problem, but let us apply this approach, which is very, very fast. Alright, so we say solubility is given as mass all over molar mass, and then we multiply by 1000 and divide by the volume of the salt in cm cube, or the volume of the solution, in cm cube. Okay, in our equation, we were given mass. The mass of the salt is 10.1 gram. Look at it very well, 10.1 gram. Okay, so that is the mass. Then also, in the equation, we are also given the volume of the solution to be 50 cm cube. But we were not given molar mass of that salt. We were not given molar mass of that salt. Okay, now, the formula for potassium triazonitrate 5 is given as KNO3. This is potassium triazonitrate 5. So first of all, we have to find the molar mass of potassium triazonitrate 5. So we find the molar mass. Okay, we say Mn of KNO3. This simply means molar mass of potassium triazonitrate 5. Okay, we solve it this way. We simply add the atomic masses of all the elements that make up this salt, or that make up this compound, or that make up this molecule. So the first one is potassium, and of course the mass of one atom of potassium is given to be 39. Okay, the next one is nitrogen. The mass of one atom of nitrogen is 14. Alright, the next one is oxygen. Remember, there are 3 oxygens, so each of the oxygen has a mass of 16. So we have to multiply by the number of atoms in that compound, which is 3. Alright, we close our bracket here. Everything here should be 39 plus 14 plus 16 times 3 is going to give us 48. So when we add everything here, all should give us 101 gram per mole. 101 gram per mole. So we have been able to find the molar mass of potassium triazonitrate. So we can now substitute into our expression or our formula, which says solubility is equal to mass. Remember, the mass we were given in the equation to be 10.1 gram. So mass is 10.1. Molar mass, we calculated it to be 101 gram per mole. Okay, we multiply by 1000 and then divided by the volume of the solution, which is 50 cm cube. 50 cm cube. So this is just very, very as short as simple. Let us get our answer. 10.1 divided by, sorry, this is 101, not just 10 gram. So not there. So 10.1 divided by 101, then multiply by 1000 and divide by 50. So it's going to give us 2. The answer is going to be 2 moles per dm cube. 2.0 mole per dm cube. So from our calculation here, our correct answer is option letter B. Our correct option is option letter B. There are other ways we can express solubility. There are other methods we can use to calculate solubility. But this one appears to be the shortest and fastest means or method of calculating solubility. This, if you have any problem on calculation of solubility, solution, and any other topic related to solution, please do well to give me a comment, like, share, and follow my channel. My channel is Eugene TV on YouTube. You can also watch or follow me live on TikTok at Eugene TV 101, so you can watch so many videos, and then of course you stand a chance to learn a lot and a lot. Send a question. If you have any question, send it directly to my DM and I'll answer you in the second line. Bye and bye for now.